Hello lovelies, in this video the brilliant Mr. B is going to be taking you through integration by parts. Now in this video there are lots of examples worked through nice and slowly, so you can jump in using the timestamps down below wherever you feel most comfortable. Take it at your own pace, not worry about what the person sitting next to you is doing, or not worry about the teacher needing to move on. Once you've got to grips with these examples, written them down neatly for your notes, then you can go over to my website and have a look at the loads of questions that are waiting up there for you.
Integration by Pertz, and this is a technique you can use when the different kind of parts of something you're integrating are being multiplied together. Now, what we've looked at so far is if we imagine these were added together instead. So we'd have 8x plus cos of x. So if we were to integrate this, we'd integrate the 8x, which would become the power of the x would go up by 1, and we divide the 8 by the new power. Then with the cos, if you integrate cos, you get sine. And then when you integrate, you've always got a plus c as well, because when you differentiate a number, it kind of goes away. So you don't know if there was a number there or not. And we can simplify this, 8 over 2 is going to be 4, so it'll be 4x squared plus sine x. So this is what happens when you've got separate terms. You can just integrate each separate term separately. Now, with this question, the terms aren't separate because they're being multiplied together. So it's 8x cos x, they're being multiplied, they're not being added. So we need this new technique, we need to use integration by parts. So what we say is, if we're integrating something, and we've got two parts to it, we call these parts u and v dash. That's going to be equal to u multiplied by v, take away the integral of v multiplied by u dash. So what do those bits mean? Well, the dashes just mean that you've differentiated it. Obviously, the integral sign means you integrated it. So when we apply this to what we've got here, we've got to split it into two parts. So firstly, we'll just discard the integral notation, the integral sign, and the dx. So what are our two parts? So we've got a kind of an x section, 8x, and we've got a trigonometry section, the cos x. So we call these u and v dash. At this point, it might be helpful to write out a little table what everything means. So firstly, we've got u. We know that u is equal to 8x. It's in the question. Now, u dash, if we differentiate u, we differentiate 8x, you get 8. So we differentiate, you're reducing the value of the power by 1. So if it's an x, it means x to the power 1. If you reduce the power to 0, then the x is going to go away. Then we do the same thing with v. So we have v. We don't know what that is yet because it's actually v dash in the question, which is cos x. So if we're going down from u to u dash, from v to v dash, we're differentiating. The opposite is integration. So we're going from v dash to v. We've got to integrate. And if you integrate cos, you get sine. Now, there's one more that we need. And if you look at the answer to this, it's going to be uv. Well, we've got that already. That's good. But then we've got the differential of v. So we're actually going to go up a level from the v. And we're going to integrate for a second time. Now, if you integrate sine, you get cos. There's a little bit of a trick twist in that if you integrate negative sine, you get cos. So you integrate positive sine, you'll get negative cos. Now that we've found these, we've got everything that we need to substitute into the answer. So it's going to be u times v. So u is 8x, and v is sine x. Then we're taking away, so the integral of v, which is negative cos x, and multiplying that by u dash, which is 8. Now we can clean this up a little bit. So for example, a double negative, we can write that as a positive. And then having the number at the end, let's be consistent, let's put the number at the front. So rather than having cos x times 8, why don't we write it as 8 times cos x? And that lets us just pop the 8 at the front like this, without any extra symbols. And actually that's our answer. So if you integrate 8x cos x, then you get 8x sine x plus 8 cos x. And finally, to remind you what this actually means. So when you integrate, if we had a line y equals 8x cos x, then what we could do with the integrated version is that would be the area underneath that curve, the area between the curve and the x-axis. Now, you might have noticed already, I kind of gone through how to integrate and differentiate really quickly. So if you're not confident with integration or differentiation, go and watch the videos on those first. One thing we should add is we need to have the plus C on the end. And again, I only forgot to do this, I always do. It's something that's really easy to miss, especially since a lot of the next steps you'd use are about kind of either finding the C or ignoring the C. But if you're just doing a normal integration, you've got to put the plus C on the end. So moving on to our next question. So let's write in the rule for integration by parts first. So the integral is going to be of u and v dash, and that's going to equal u multiplied by v, take away the integral of v u dash. So first identify what u and v are. So ignore the integral notation, that's just telling it that we're integrating. And we've got two sections, we've got an x section and we've got a trigonometry section. So they are going to be our u and our v dash. So now we just need to make a little table of all the different possible things we might need for this, starting off with the u first. So u is equal to 4x. So u dash, differentiating u, would be 4. Again, you reduce the power on the x when you differentiate, and you multiply by the old power. The old power is a 1, so effectively just drop off the x when it's a single x. Then we're going to have a look at v. Now we're going to start at v dash because that's what we're given in the question, which is sine x. And we're going to need v, and we're going to need the integral of v as well to substitute. So we're going to integrate twice. So if you integrate sine, you get cos, and if you integrate cos, you get sine. The tricky thing with this is negative numbers, and it's actually a negative sign will integrate to cos. So a positive sign will integrate to negative cos. Then a positive sign integrates to a positive cos, so a negative cos would integrate to a negative sine. And again, this is all in the integration video that you should have watched first. So now we've got everything laid out that we need, we can substitute. So we've got u times v. U is 4x, and v is negative cos x. So we put the cos x on the end, put the negative at the start on the number. So it will be a negative 4 overall. Then we're going to take away the integral of v, and it's a negative, double negative is a positive, and it's sine x. We're going to multiply that by u dash is 4, and then we could put a multiply 4 at the end, but it's going to be better just to pop it at the front. Any kind of numbers should be at the front as a coefficient. So when you integrate 4x sine x, you get negative 4x cos x plus 4 sine x. Don't forget at the end to put plus c onto your answer. Now, our next example is use trigonometry. We've got the number e. So again, follow the same method. We can ignore the integral notation. We'll split it into two parts. We've got an x section, 7x, and then we've got a different section. This one's going to be an e to the power of x. This is going to be our u and our v dash. We make a little, almost like a dictionary of all the different terms we're going to be using. So u is equal to 7x. So u dash, differentiating it, is going to be 7. V dash is equal to e to the power of x. And we need to find v and the integral of v. So we're going to integrate twice to go up through this. And e is a special number, whereas if you integrate or differentiate e, it doesn't change. So all of these are going to be ex. Now we've got everything we need, we can substitute. So first we've got u times v. U is 7x, and v is e to the power of x. Then we're going to take away the integral of v, which is ex. We're multiplying that by u dash, which is 7. We'll just pop that on the front. So when we integrate 7x ex, we get 7x ex, but then we take away 7ex. Remember to have the plus c on the end. You might even want to do things like take things out as a factor. So we could even take ex out as a factor, leaving us with 7x minus 7. And we can even take 7 out as a factor as well. Now, if you just have to integrate, the first answer should be absolutely fine. Taking things out as factors, that all depends on if there's extra steps to do next, or if you're asked to put your answer in a specific form. The next question has logs. So again, identify the integration notation. Now we can focus on what we're actually integrating. We've got the x, and we've got the ln x. So we've got two parts. The first part is going to be u, and the second part is going to be v. Then we do a little list of all the possible things we might need. So u is x. That would mean that u dash differentiate x, you get 1. Then we look at v. Now we're starting off with v dash. V dash is our ln x, and we're going to need v, and the integral of v. And here's where we have a problem, because integrating ln x is quite complicated. Now you can just about do it, and it's going to be x ln x minus 1. And you'll notice this looks an awful lot like our original question. If we expand the brackets here, we're going to have x ln x, which is our question, take away 1. And then we have to integrate it. Well, integrating that is our original question. And so at this point, we can't continue. But I want to show you this because it's not always right at the start that u and v are in order from left to right. Sometimes you can do it the other way around. And that's what we're going to do in this question. So we've had a go, it's not worked. Let's swap u and v. So we're going to have v be x and u be the ln x. And we'll try it this way. So let's see what happens. So firstly, we've got our u. U is ln x. And while integrating is difficult, differentiating isn't. If you differentiate ln x, you get 1 over x. You might remember there's another form of this. You can write it as x to the power of negative 1 as well. And that will be useful in a moment. Then we've got our v, which is x. Remember, this is actually v dash. So it's going to be v dash is x. So we want to integrate it and integrate it again. So you integrate x, you raise the power. If the power's gone up by 1, you now divide by a new power. So we're dividing it by 2. Could write that as a half. And then we want to integrate it again. So we can increase the power by 1 to 3. And then we've got to divide by 3. So a half divided by 3 is going to be a 6. So these are the building blocks that might be useful here. Let's see what happens. So we're going to have u multiplied by v. So u is ln x, v is a half x squared. So we could write half x squared ln x. Then we're taking away the integral of v and u dash. Now, I did a little bit of a shortcut with this before, where I kind of treat these as being separate. But actually finding the integral straight away is not always helpful, especially when it's more complicated like this, because really it's actually the integral of v multiplied by u altogether. So what we could do is we could write it as the integral of v, which is our half x squared, multiplied by u dash, which is x to the power of negative 1. And you might notice something here. We've got two of the same bases together, x and x. They've both got powers. We can use the laws of indices here. And so by multiplying the numbers before integrating, sometimes you can cancel out to get something a little bit easier to use. So actually, this is going to give us, first bit's going to be the same, but then x squared and x to the minus 1 together, if they're being multiplied together next to each other, you add the powers. So it's going to give us a half x overall. Power 2 and power negative 1 cancel out to make power 1. And so now we're actually going to integrate half of x. And the integral of half of x, we are going to increase the power by 1, x becomes x squared, and then we'll divide by the new power. So we've got a half, you're going to be dividing by 2, well, we're already dividing by 2 twice, it's going to be dividing by 4. And so now we can go back up to our original question. Again, the first bit hasn't changed at all through any of this, but now the second part, we're taking away a quarter of x squared. So the big thing to take away from this question is that you can use this kind of simplified method for the first few questions that we went through, where we integrate the v. But you are going to get questions where sometimes before integrating, it might be useful to combine the kind of number sentences together first to get something that's easier to integrate. Another thing to consider is that having u and v, the order matters, and sometimes having it in a different order is going to lead to a possible integration. Sometimes in the wrong order, it won't be a possible integration. At the end, remember, we're always going to need a plus c when we're integrating. So let's look at another example like that. So again, we've got our integration notation. We've got two different parts, the 5x and the ln x. But remember, from last time, having the ln go first is helpful. So we'll have the ln as u, and we'll have the 5x as v dash. So looking at u first, u is equal to ln x, and we're going to need u dash. Differentiate ln x, you get 1 over x, which can be written as x to the minus 1, which is helpful when you're simplifying using the laws of indices. Then we've got v dash, which was 5x. So if we integrate that to get v, increase the power by 1, and divide the coefficient by the new power. So we've got 2.5 x squared. Now we could integrate v like it's helpful sometimes, but we know because we're multiplying the v and u dash, and they're both x terms, then there might be some simplification we can do before integrating. So let's substitute. So we're going to have u multiplied by v. So v is 5 over 2x squared, and u is our ln x. Then we're going to take away the integral of v times u dash. V is a 5 over 2x squared, and u dash was the x to the minus 1. And again, that's something that we're going to be able to simplify. And it's going to give us altogether, we can write the integral out separately, 5 over 2 is x squared, next to the minus 1, we're going to cancel out to make x to the 1. So if we integrate that, we're going to increase the power by 1. X becomes x squared. And then the 5 over 2, that's going to be divided by the 2. So if you're dividing something that's already got a denominator, that's been divided by 2 already, multiply them together, 2 times 2 is 4. It's going to be 5 quarters x squared. So now we can write out our final answer. The first bit hasn't changed. And the second part, we're taking away 5 over 4 x squared. Then we can have the plus c. And then, keep in mind that you can always change improper fractions into mixed numbers. So we already noted that 5 over 2 is 2.5. You could write that in. And 5 over 4 will be 1.25. So that might be an alternate form that might be useful sometimes. Again, it depends on what the question's asking for and what the next steps are going to be, if you need that or not. Now, with the medium questions, we're going to start off with something that we've done before, but then we're going to bring it on to the next question to something that's a little bit more complicated. So for this question, again, separate out the integral notation. Look at the two bits we've got. We've got an x section and a trigonometry section. One of them is going to be u, and one is going to be v dash. So then, if we know what u is, we can find u dash, which would be 2. And if we know what v dash is going to be, so that's cos x, we can find v. So when you integrate cos x, you get sin x. Now, before we then integrated v again, but we'll just leave that for a moment. Let's do a substitution. So we have uv, so that'll be 2x times sin x, and then we've taken away the integral of v times u dash. So u dash is 2, so that'll be 2 sin x. So we can then integrate the 2 sin x, and if you integrate sin, you get cos. Well, negative sign gives you cos, so this will give you negative cos. So we negative 2 cos x. And so now we can write down a final answer. The first bit stays the same, and then the second part be negative 2 cos x. So in the easy questions, I kind of differentiated v first and then substituted. So I would have found the negative cos x and then multiplied it by u dash, which is the 2. This time in the medium questions, I've kind of left that, and then I've multiplied v by u dash and then integrated second. So I've integrated the other way around, but I've got the same kind of answer we would have got before. And remember the plus c on the end. Now with the next question, we've got a very similar one, but we can see this time the angles change and we've got cos of 2x. So we can start off the same way. Identify the different parts. We have an x part and a trigonometry part. So we have u and v dash. So if we have u being 3x, you know that u dash is going to be 3. And if v dash is going to be cos of 2x, then when we find v, when you integrate cos, you get sine. So it's going to be sine of 2x. Now, the difference here is the angle, and if there's a coefficient on the x in there, then that can come out. So when you differentiate, you kind of multiply by it, and when you integrate, you divide by it. So if we divide by that 2, we're going to get a half. So now we can substitute. U times v is going to give us 3x multiplied by a half of sine 2x. And we can simplify that. 3 times a half is going to give us 1.5. Or we could write it as 3 over 2. Then we're going to take away the integral of v times u dash. So u dash is 3. V is a half of sine 2x. And if we integrate that, if we integrate the sine of 2x, then integrating a sine will give us a negative cos. So a double negative will give us a positive. Then we're going to be dividing by the 2. So we're already dividing by 2 with a half. So we'll divide by 2 twice, it'll be a quarter. And we're multiplying by the 3 as well. So it's going to give us 3/4 altogether. And then we're going to have the plus c at the end. And then after this might be another step. It might be you want to change 3 over 2 into 1.5. Maybe you want to take things out as factors. But again, that depends on what the question is asking you to do next. Let's look at another example. So again, just ignore the integration notation once you know it's integration. We're going to find our 2 parts. We've got the x part, which we're going to have as u. And we have the sine part, which we're going to have as v. Or rather than a question, it's going to be v dash. So we can use those 2 parts to find out the rest that we need to substitute. U is 2x, so u dash is 2. V dash is sine of 3x. So we'll integrate that to get v. If you integrate sine, you get negative cos. The angle doesn't change, but we have to divide by the coefficient on the x, which is a 3. So we divide by the 3, which gives a negative third cos 3x. So let's substitute. U times v is going to give us 2x times a third of cos 3x. And that was negative as well, so we've got to put a negative symbol in there. Then we're taking away the integral of v times u dash. So that's a negative third cos 3x multiplied by u dash, which is 2. So we can work these bits out. So negative 2 times a third is going to give us a negative 2/3 of cos 3x. And then we're going to take away, so we've got negative 1/3 times 2, which will give us a negative 2/3. We've got the cos. If you integrate cos, you get sine. But when we integrate, we're going to divide by the number on the x. We're dividing by the 3. Well, we're already dividing by 3. So divide by 3 twice, that'll be divide by 9. So altogether, it's going to be negative 2/9. And we have a double negative, which will mean it'll be a positive. Now, I'm starting to do a lot of the number terms all at once here. So, feel free to do it step by step. So, we could do a negative third times 2 will give us a negative 2/3. Then you might think, well, then we've got the negative 2/3. And then when we integrate, the 3x will split out the divide by 3. And then that gives us the negative 2/9. So you do it step by step. So it kind of depends on how confident you are with your fraction skills. And again, at the end, remember to have the plus c. Now, the next example, the same thing, this time the coefficient on the x when we have an e. So again, let's start off the same way. Identify the different parts we're going to be using. Which ones are going to be u and v dash. So the u is 7x, so u dash will be 7. V dash is e to the 8x. So with v, when you integrate or differentiate e, it stays the same, so it'll still be e to the 8x. Remember, when you differentiate e, the number on the x is going to come to the outside, so you get 8 e to the 8x, but we're integrating, so we're going the opposite way. So we're going to be dividing by the 8. And the way to divide by 8 is to multiply by 1/8. So now we can substitute. We've got u times v. So we've got 7x multiplied by 1/8 of e to the 8x. And we can simplify that. So 7 times 1/8 will be 7/8. Then we've got our integral part, v times u dash. Might be helpful to u dash found first, that's 7. And then the v is going to be 1/8 of e to the 8x. So altogether, that's going to give us 7/8 e to the 8x. And we know that when we integrate this, what's going to happen is the e's can stay the same. It's still going to be e to the 8x. However, we're going to divide by the 8 again, and we're only dividing by 8. Divide by 8 twice, you divide by 64. So we 7 over 64, e to the 8x, and of course, we have the plus c. For our last medium example, so again, start the same way. Now, if you remember, when you have ln x, it's usually easier to have that as the u. So when you've got your two terms, they could be either way around. So choose which one's u and which one's v carefully. Usually x is suitable to be u, but in the case of ln, it should be the v. So if u is equal to ln 6x, now when you differentiate that, it's going to be still going to be 1 over x. It's not going to be 6 over x, something like that. It was x to the power of 6, then it was 6 over x. So it kind of the powers come out with ln, not the coefficients on the x. And we can write that as x to the power of negative 1. Then we have v dash, which is 8x. So v, if we integrate that, raise the power, and divide by that power, 8 divided by 2 is 4. So now we can integrate u times v, give us 4x squared, ln 6x. Then we're going to take away the integral of v u dash. So v is 4x squared, u dash is x to the minus 1, and we can combine those together to be x. So then we can write out our final answer. We've got 4x squared ln 6x. So if you integrate 4x, the power increases from x to x squared, and you divide the coefficient by that new power. So 4 divided by 2 is 2. So our final answer is 4x squared ln 6x minus 2x squared plus c. Moving on to the hard questions, we have more complicated expressions. Here you can see we've got multiple terms in each part. So we analyse what we have. We've got our x part, which is our 2x minus 1. So now it's two terms altogether. But the whole thing's in a bracket, so it's kind of combined together. Then we've got our second part, which is the cos x plus 3. So as usual, we've got our u, and we have our v dash. So if u is 2x minus 1, u dash, differentiate the 2x for 2, and differentiate the negative 1 to get 0. Then we can look at the v dash. V dash is the cos of x plus 3. So if you integrate that, if you integrate cos, you get sine. So that'll be the sine of x plus 3. And there's no numbers coming out, there's no dividing here, because it's when you've got a coefficient on the x that comes out. If it's just plus or minus on the x, then it doesn't. So now we can substitute u times v. So we're going to do 2x minus 1 multiplied by the sine of x plus 3. Then we're going to take away the integral of v times u dash. U dash is 2, so that'll be 2 times sine of x plus 3. So simplifying these terms, there might be some situation where we expand this bracket, but for now it should be easier just to keep it in brackets. So there's no need to do 2x times sine or negative 1 times sine. We can just leave it as that. Then for the integration, when you integrate sine, you get a negative cos. Like there's a double negative, so it'll end up being positive, and that'll be 2 cos x plus 3. Remember to add c on the end, and we've got our final answer. For our next example, again, we are integrating. We've got an x bracket, and we've got some trigonometry. That's giving us u and v dash. So if u is equal to x plus 5, differentiating that, differentiate x, you get 1. Differentiate 5, you get 0. Then we've got v dash, which is cos of 2x plus 4. So we need to integrate to get v. When you integrate cos, you get sine. The angle doesn't change. But we've got that 2 on the x, so if we're integrating, we'll divide by that. So that'll give us a half if we're dividing by 2. So now we can substitute. We've got u times v. U's got 2 terms, so put it in brackets. And multiply it by the v, which is half of sine 2x plus 4. Then we're taking away the integral of v times u dash. Now u dash is 1, and we multiply by 1, it's not going to change, so no point writing that down. And the v is half of sine 2x plus 4. So we can simplify this, clean it up a little bit for our final answer. You could put the half first on the bracket. And then with the integration, if you integrate sine, you get negative cos, double negative, you're positive. So that'll be, it's not going to be a half, because when we get the cos of 2x plus 4, that 2 is going to come out again. And if we're integrating, we'll be dividing by the 2. We're already dividing by 2, divide by 2 twice, and you're actually dividing by 4. So it's not going to be 1 over 2, it's now going to be 1 over 4. It's going to be a quarter. Remember to add c at the end, and we have our final answer. Next, we have another example where the x is in 2 parts, and then we've got e for this one. So the x is x minus 7. That's going to be our u term. And then we've got the e to the 4x, which is going to be our v dash. So if u is equal to x minus 7, then u dash is going to be 1. If v dash is equal to e to the 4x, remember when you integrate this to get v, e is not going to change. It's still going to be e to the 4x. However, we've got the 4 on the x, so if we integrate, we have to divide by that. So now we can get this all together and substitute. Just make sure my v's actually look like v's, so let you use there. Very easy mistake to make. You don't get confused mixed up with v's and u's. So u times v. U's got 2 terms, so keep it in brackets. So let's make it less complicated. And v is a quarter of e4x. Now, I'm multiplying those together. One little trick is going to be just put the quarter at the start. You can multiply the brackets if you want to, but you're going to end up with 7 quarters, which is going to be not the nicest number to write down. So it's better to leave it as it is usually. Then we're going to take away the differential of v times u dash. Now, u dash is 1 again, so we don't need to write that down. Times by 1, it stays the same. But v is a quarter e to the 4x. Now, we know that if we integrate e, it's going to stay the same. It's still going to be e to the 4x, but we're going to divide by 4 again. 4 times 4 is 16. So altogether, we're divided by 16. Add c in the end, and you have your final answer. Now, again, there might be more things you can do here. You might want to take e to the 4x out as a factor. You might want to expand some brackets. But again, you're going to be told in the question, you need to have it in a specific format. The next question, we are integrating 8x minus 7 and e to the 7x. So we have u and we have v dash. U is equal to 8x minus 7, so u dash is equal to 8. V dash is equal to e to the 7x, so v is equal to, e is not going to change, still e to the 7x, but we're going to divide by the 7 when we integrate. Does that mean differentiate? You'll be multiplying by the 7. So we can substitute u times v. U is 8x minus 7, and v is a 7th of e to the 7x. So you might just want to rearrange that and put the 7th first. And just watch it, you can divide through by 7 with a bracket. You can't for this, you can divide 7 by 7, but not the 8. So it's probably easier to leave it as it is. Then we're taking away the integral. V is going to be a 7th e to the 7x, and u dash is 8, so multiplying by 8. So altogether, it's going to get 8/7 e to the 7x. Now, when we integrate it, we know that e is going to stay the same, e to the 7x, but we're going to divide by the 7 again. So 7 times 7 is 49, and we're times by the 8, which will go on top. So we have 8/49. Add c at the end, and again, we've got our final answer. And just be aware of different things you can do. You can try and simplify the fractions. You can't with 8/49, but it's worth looking at. Maybe you could expand the bracket at the start. Perhaps you could take e to the 7x out as a factor. Again, all dependent on what any possible next steps are, or what format the question is asked for the answer to be in, if any. For our last question, again, it's another integration, and this time we've got ln 5x in here. We know that ln is more suitable to be the u part of this from previous questions, which means the x part of this, the 4x plus 8, this is going to be the v part. And the question is going to be v dash. So u is equal to ln of 5x. So u dash, differentiate ln, and you get 1 over. That'll be 1 over x. And 1 over x is going to be x to the power of negative 1. Then looking at v dash, if v dash is equal to 4x plus 8, then v, we're going to integrate this, we're going to increase the power. So x becomes x squared, and we're going to divide by the 2. 4 divided by 2 is 2. Then the 8 doesn't have an x, so we're going to have to put 1 on. So now we can substitute. You've got u times v. So we could write the v first, perhaps. So 2x squared plus 8x multiplied by ln of 5x. Then I'm going to take away the differential of v times u dash. So that's going to be v is 2x squared plus 8x. And that's going to be multiplied by x to the minus 1. And so what that's going to do to this is it's going to reduce the powers by 1, because laws of indices, add the powers together, add on minus 1, the power is going to go down by 1. Actually, what we're integrating is going to be 2x plus 8, because we just reduce the powers by 1 because of the x to the minus 1. Now, we can do that integration. Now, the first part's not going to change. We've already got that in the simplest form. We can get it. When we integrate 2x plus 8, x is going to go up by 1 to x squared, and we're going to divide 2 by the new power. 2 divided by 2 is 1. So we just have x squared. Then we've got the 8. So if you integrate 8, you're going to get 8x. Remember, we're taking away this integral, so we're actually taking away the 8x. We're taking away everything in this second part. All we have to do now is have the plus c at the end, and again, we've got our final answer.